Hi, this video is going to talk about slopes. So you spoke about slope significantly when you took Algebra 1. Slope is where you are trying to find the steepness of a line. So when you were doing slope, similar to how we did distance and midpoint formula, it revolves around having 2 points, knowing that x is the first coordinate, y is the second coordinate. X is the first coordinate, y is the second coordinate. And then my subscripts indicate the first point and the second point. So since P1 stands for the first point, there's my x1, y1. P2 is my second point, there's my x2, y2. So there's several different variations of the slope formula. Probably the two that you are most familiar with from Algebra 1 are the rise over the run and this y2 minus y1 over x2 minus x1. So they're the two that you're the most familiar with. These other notations, your algebra teacher may or may not have mentioned them. I like to include them every year that I do slope because it keeps coming around. So when you take higher level math classes, you will see it notated in different ways. Sometimes we notate it as the change in y over the change in x. You may have even had an algebra teacher who wrote rise with a y in it instead of an I. This triangle is delta. If or when you ever take a physics course, you often see this delta y, which delta is just the mathematical symbol that means change in. So these are both other ways of saying it. And then to mathematically calculate that change, you are going to subtract your y values and subtract your x values. Now you're going to see I have this little statement written right after it, and that's just a statement that we as mathematicians write to remind you that if the two x values were equal to each other, this would be undefined. And so that's why we say if the two x values happen to equal each other, so you have the same x value in any of your points, it's going to create a vertical line. And from Algebra 1, vertical lines always have a slope which is undefined. So I have types of slopes, and I have 4 different graphs represented. So the first one I'm going to draw is that vertical line, and I'm going to remind you that that's always an undefined slope. So if you plot your points and you get a vertical position on your 2 lines, it's always going to be undefined. You may have heard of Vux. Vux is if it's vertical, it's an undefined slope, and the equation is x equals. The next type of line you may remember from Algebra 1 are your horizontal lines. Horizontal lines are a slope of 0. And you may have heard HOI as the abbreviation we often assign to 0 slopes. That's because horizontal lines have a 0 slope and the equation is y equals. These two are the most commonly mixed up slopes. One thing I usually remind people about is thinking about cross-country skiing. You can cross-country ski on flat land. There's just 0 slope to ski on. Versus you're not going to be skiing down the side of a building. It's undefined. It's impossible to do. Okay, so those are the ways I usually try to trigger that into your memory. The other two are, as you read from left to right, a line that is increasing or going uphill always has a positive slope, and a line which is decreasing or falling as we go from left to right always has a negative slope. So those are just the 4 reference graphs for you as you're looking at slope. So if you're ever given visually a graph and asked to find the slope or identify the slope of a line, you can first in your head think, should my answer come out positive, negative, 0, or am I going to end up having an undefined scenario? Well, what do we do with slope now that you're in geometry? Now that you're in geometry, we start looking at pairs of lines and talking about them and how does their slope relate to one another. So the first scenario are parallel lines. Remember that parallel lines do not cross or touch. So parallel lines, if I take 2 markers here that I have sitting off to the side, would be they're just running side by side. They're going to have the exact same incline, but neither one is steeper than the other, but they will never touch each other. I can tilt them this way, have that same scenario. I can be vertical. Notice all vertical lines are going to be undefined slopes, and they can be horizontal. All horizontal lines are always going to be zero slopes. So with that in mind, parallel lines always have identical or the same slopes. But their y-intercepts are going to be different. So they're going to have identical slopes, but they're going to have different y-intercepts, meaning that if I drew a parallel line up here under this positive, one is crossing here above zero, one's crossing below zero, but they have the same amount of incline. Neither one would be more difficult if you were going backpacking up that mountainside. Now, when we go into perpendicular lines, those are going to be a little different from each other. So if I bring my markers back into the mixture again, perpendicular are two lines that always cross at a right angle. So they have to cross at a right angle. And a right angle is 90 degrees. So that means when I make these two pens be perpendicular, I need to make sure that the corner where they cross is 90 degrees. So oftentimes what I use is, like for instance, I have this notepad here. If I put it in here that I know the corner is 90, that kind of just straightens out my pen so that I know I'm looking at a 90-degree angle. So this is the idea of what perpendicular lines will look like. Well, if I have one vertical and one horizontal, those are perpendicular. If I start to tilt my pair of lines, you're going to see that when they're tilted, you're always going to have one positive and one negative. So I have one zero, one undefined, one positive, one negative, depending on which way they are tilting. That's because the name for the types of slopes that we have is they are opposite. Opposite, meaning one's positive and one's negative, and they are reciprocals of each other. Reciprocal means if one is going at an incline, so let me do perhaps like this scenario. If this line is going up at a very slow incline, maybe it's going up one, rising one for a run of two, rising one for a run of two, versus my red line might be running one, but falling two, running one, falling two, much steeper. I know example-wise, I grew up in a much older house, and a lot of older houses have much steeper staircases, meaning the rise is definitely more than the run. So that's this red pen scenario. Whereas if you're going to run in like a stadium set of staircases, its run is usually longer because it's going to be a shorter step up, but then there might be a longer like footpad for yourself. If you multiply the slopes together of two perpendicular lines, the product should always equal -1. So that's just a check for yourself. When you find the two slopes and multiply them, it'll always equal -1. So I put in simple terms here that you're going to flip and change the sign. Reciprocal means flip. Opposite means change the sign. So down here at the bottom, I have given you a set of ordered pairs. And with that set of ordered pairs, I've asked you to do three things with it. I've asked you first to find the slope of the line, just as you would have done in Algebra 1, using this formula I have highlighted up here above. Then, after we find the slope of the line, we're going to find the slope parallel, and then we're going to find the slope of a line perpendicular. So that means we're going to use these two pieces of information to identify the parallel and the perpendicular slope. So, let me show you how to do that. I'm going to do the first one with you, and then I'm going to ask you to try the next two. So let me refocus that. There we go. So the first one. So I'm going to remember the slope formula. So I'm going to go ahead and write that down here. It's y2 minus y1 over x2 minus x1. So when I do my slope, I'm going to fill in. I know that I have x and I have y, x and I have y, my first point and my second point. So when I fill in my formula, and we use a lowercase m for slope, if your algebra teacher didn't tell you, it's actually a Latin base. It's for the Latin word for mountain, which is mons, M-A-N-S. So that's where that m comes from. It's a very Latin origin. So I'm going to subtract my 6 minus my 7 and my negative 4 minus my 3. When you're doing slope, you do the problem on top, do the problem on bottom, so numerator, denominator, and then you try to simplify. Slope should always be a fraction or a whole number. Please do not make it a decimal. Please do not do an ordered pair. Slope is always going to be a fraction or a whole number. So when I take 6 minus 7, that's going to give me negative 1 in my numerator. Negative 4 minus 3 is going to give me negative 7 in my denominator. And I always want to look at these and say, well, can I reduce it? A negative divided by a negative is going to turn it to a positive 1/7. So that would be my slope for these points. So now part B says, let's find the slope of a line parallel. Well, the symbol for parallel, I'll write this right over here. The symbol for parallel is always two vertical lines. So when I ask you to find the slope of a line parallel, I'm going to call that M, and I'm going to beside it make a subscript of two parallel lines. And what that tells the reader is I'm finding the slope parallel. Well, if I go back to my definition, it says parallel lines have identical slopes. So if they have identical slopes, if this is the slope of the line, if I were to find another line having being parallel, it would also have a slope of 1/7. So my answer for A and my answer for B should be identical because parallel lines are identical slopes. Now, the symbol for perpendicular is an upside down T. So when I come down here to part C and it asks me to find the slope perpendicular, I'm going to use that M for slope, and then the upside down T means perpendicular. Well, going back to my rules, what do I do for perpendicular? I need it to be the opposite, and I need it to be the reciprocal. Opposite means I'm going to change the sign. That's what opposite means. And reciprocal means I'm going to flip it. So when I come down here to my fraction, if I'm currently 1/7, when I want to be perpendicular, I'm going to flip it and change the sign. So it's going to go from positive to negative. I'm going to flip it and make it 7/1. And just like we did up here, if you can simplify it, we should. So that negative means the whole answer is negative, and 7/1 is a negative 7. So remember that whether I write negative 7/1, whether I write 7/1, or whether I write negative 7/1 with that negative sign out front, those all mean the same thing. So they all have the same meaning. What is different is, such as this example, a negative and a negative, that actually turns positive. So anytime you're dealing with a negative with a fraction, it can be in the numerator, the denominator, or out front. So you take a moment, pause the video, and try these two examples yourself. Okay, I hope you've paused the video. Welcome back. And you can probably read through my sticky notes a little bit, but pretend you can't for a second. So this second one, I had you try that one. So I'll reveal. You should have had a slope of 6, and you should have said that the slope parallel would be 6. That's because when I take 9 minus 3, I get the 6. Negative 1 minus negative 2, be careful of those negative signs, becomes a positive 1, which when I simplify that is a whole number of 6. So you should either have a fraction or a whole number for all of these answers. The slope parallel is going to be identical. That's going to be 6. And the slope perpendicular is where I'm going to flip and change its sign. So I'm thinking of this as 6/1. So when I flip it, it's a 1/6. And that negative can either be in the numerator, the denominator, or out front. So any of those are acceptable answers. So now this side. What happens when I take the 5/8 and the 5-4? When I fill in my formula, you should end up with -4 minus 8, which is -12, 5 minus 5, which is 0. When 0 is in the denominator, do not leave your answer like this. Probably one of the most common things I mark wrong during the slope section is people will leave their problem right here. That is not the actual slope. The actual slope is undefined. And the reason it's undefined is if you take a calculator and you take 12, or we should say -12, divided by 0, the calculator is going to error on you. It's going to say error, you're trying to divide by 0. And that's because it's impossible to take a number and divide it into nothing. So therefore it's undefined. So the slope parallel is also going to be undefined. But now the trick comes into be, well, what am I going to do with perpendicular? Well, the reminder comes from, if I slide my book back down, remember that undefined comes from a vertical line. So what is perpendicular to everything that's vertical? Horizontal. So when you were doing C, this was my trick. You didn't maybe know what to do with the numbers. Well, you could have switched the 0 over -12. And if you come to the calculator and try to take 0 divided by -12, you'll see that it is possible. It will become 0. And that's because perpendicular is always 0. So undefined comes from vertical, 0 comes from horizontal, and those two are perpendicular to each other.